Okay. Uh, we've seen this before, but I think it is beneficial for us to do this again. So we did this 2 days ago. I'm going to ask you to do it Tuesday on a quiz, 5 to 8 minutes. Okay, so you're gonna really understand what we're doing here. But we've already talked about this. Can you count to 2 by 6s, or can you count to 12 by 1s? Okay, and can you count to 2 by 4s, or essentially 8 by 1s? Right? We can all do that. That's all this thing is. Okay. Now, as we work through, so the last class was like, well, I'm just going to memorize the positions of these things. You're going to get yourself in trouble by doing that, okay? And I want you to understand the relationships of these fractions and all that kind of stuff, because eventually what we're going to do is we're going to take some points off of this circle, okay? So let's do the first quadrant here real quick, okay? First quadrant, you guys know, halfway through pi over 4, yes? Okay? We talked about that being on the line y equals x, correct? Okay? And that's associated with what degree? 45 degrees, okay? So I'm going to interchange, and it's just the way that my mind, how I was programmed to do this, and I've got to kind of deprogram myself. I will flip-flop back and forth between talking about theta, the central angle, or the distance on the circumference here, okay? Remember, in the unit circle, though, okay, if this is theta, okay, we were calling this, some textbooks call it T, some call it S, whatever, right? But we know that S is equal to R theta. That's the arc length formula when theta is in radians, correct? And because we're in the unit circle, R is 1, so S is theta, or in our case, T is theta. Does that make sense to everybody? That's the connection. So as we do this, I'm going to say, pi over 4, theta is pi over 4, or the angle is pi over 4. But in the next one, I might say the distance is, pi over 3 or pi over 6. So I might get that flip-flop confused, but it's the same thing. So it's an equivalent argument. All right. The other one that we're interested in is pi over 6. Okay, pi over 6 is right here. Pi over 6 is equivalent to what degree? Radian, or 30 degrees. So in radians, it's pi over 6. In degrees, it's 30 degrees. Is that closer to pi over 4, or is it closer to 0? Pi over 4. So make sure that you've got things scaled that way, because eventually, when we take this into the next section, and we look at the functions graphed in the xy plane as a theta comma y or theta comma x, the positioning of those is important, okay? Because it'll basically, our graph, we want it to be to scale, all right? So we need to make sure pi over 6 is closer to pi over 4. Obviously, we've got 0 here, 0 radians, 0 degrees. This one here, okay? And this is where I was talking about being able to count by 6s. If that's kind of the smallest distance that we're going to talk about right now with our unit circle, or it's the smallest angle if we think about the central angle. I like to call that my index. It's my counting tool, okay? So if that's my index, basically what I'm going to do is that's my smallest distance that I can use to create the positions of the other points that we go through and look at, right? Does that make sense? So I'm going to take that distance, and I'm going to add it to itself. Well, if I take that distance and add it to itself, I was hoping I'd rotate a little bit better. Take pi over 6, add it to itself. Doesn't it get me right there? So that would be 2 pi over 6, okay? Now, hopefully we're at the point where we can do this. If it's 2 pi over 6, that's going to reduce to pi over 3, okay? Pi over 3 is 60 degrees, okay? Take that pi over 6, add it to itself again. Okay, so when we're adding, because everything's in terms of 6s now, we're just counting the numerators, right? Going from 1 to 2 to now 3. So it'd be 3 pi over 6, or pi over 2. And that ends up being 90 degrees, okay? Now, as you go through like a calculus book, okay, many of you are signed up to take calculus, right? As we open the first cover of the calculus book, that picture is in it. Now, it's going to be a little bit more detailed, but that picture is in it, okay? When we get into calculus, one of the hardest things for students is to jog their memory with what we did with this trigonometric work, because they're going to work with trigonometric functions in calculus. Does that make sense? We're going to integrate them. We're going to differentiate them and that kind of stuff. We're going to do the main two operations in calculus with trig functions, and it gets confusing for people because they forget this. Okay, so it's going to be something we have to carry with us throughout the entire year and into next year. But once you have this, everything else is built off this. Now, we're going to keep walking around here, but what I want you guys to do real quick for me is tell me what these ordered pairs should be for 0 degrees. 0, 1. Is that right? Should be 1, 0. Okay? So 1, 0, because of the unit circle, right? The unit circle is the radius. Radius is 1. What is this one going to be? Okay, so we know that as we work through the entire unit circle, there are two values other than 0 and 1, but in radical 2 or 2. But there's two values that show up a lot, radical 3 or 2 and 1/2, right? Those are the ones that are really different. Okay, radical 2 or 2 and radical 2 or 2 is always going to be the pi over 4 locations. Which one's bigger, radical 3 or 2 or 1/2? Radical 3 or 2. So if I'm going, remember, and this is what can help you remembering that we are in the coordinate plane. We talked about that the other day. A lot of people forget that this is inside the coordinate plane, right? We're from -1 to 1 on the x-axis, -1 to 1 on the y-axis. If I'm going from 0, 0 to that point, traveling rectangularly, which means I'm traveling by horizontal and vertical lines, right? That distance right there is what compared to that distance? It's bigger. Well, what number is bigger? Radical 3 or 2 or 1/2? Radical 3 or 2, okay? Because what happens, and somebody will do this, on your quiz, they will make this 1/2 radical 3 over 2, and they'll make this one radical 3 over 2 1/2. Does that make sense? They'll flip-flop them. But if you can remember that relationship, that we're actually traveling in the unit circle, or the coordinate plane to get on the unit circle, that might help with that ordering. Eventually, I forget what chapter it is, maybe chapter 8, we'll talk about polar coordinates. Because won't you guys think it's easier to go from here straight to that spot? Polar coordinates are something that allows us to do that. Those of you that have worked with vectors in physics, you talked about vectors, right? Okay. So that will all be encapsulated later on, how I can go from 0, 0 to there in a more efficient way. All right. What do we know about the line? What was the line that passed through pi over 4 when we determined that pi over 4 was that point on the circle was located at radical 2 or 2, comma, radical 2 or 2? What was that line that went through here? X equals y, y equals x. So what do you know about this point here in comparison to that point there in regards to that line y equals x? Good, the reflections. So if the reflections across line y equals x, that means those points are inverse points, right? So if this is A, comma, B, then this one becomes B, comma, A, yes? All right, and we got this one being 0, 1, correct? All right, so usually that is what you see in a calculus textbook. If you were to Google unit circle or something like that, usually that's what comes up, or a lot of times they only give you the first quadrant, okay? We talked about reference numbers 2 days ago. We talked about reference angles in chapter 5, right? Those reference numbers or reference angles, the purpose for those is so that you can find, you know, the sine or cosine of 5 pi over 6, okay, by referencing that it comes back to pi over 6. But on your quiz, I'm going to ask you to go all the way around, okay? So let's continue working all the way around. So let's count by 6s. So 1, 6, 2, 6, 3, 6, 4, 6. Okay, but if I have 4, 6, what's that reduced to? 2 pi over 3. Okay, I'm going to put this one down here, 5, 6, and then 6, 6, right? So that's pi. And then we get 7, 6, 8, 6, which is 4 pi over 3. We already had this one. This was 9, 6. Just 3 pi over 2, right? 10, 6. 11, 6. and then we get back up to 12, 6, right? So that's pretty straightforward, counting from 0 to 2 by 6s. All right? Reducing the ones that I'm going to ask you on your quiz, don't write 8 pi over 6, write it as 4 pi over 3. Okay? Now we're going to go count by fourths. So we went 1/4, so it's really a new index, 1/4, 2/4. This one would be 3/4, 4/4, 5/4, 6/4, and then 7/4, and then back up to 8/4, right? In my opinion, those are the most important parts of the unit circle. Because when I ask you to eventually investigate what does the sine function look like, okay, as a graph in two-dimensional space, or what is the cosine or the tangent, secant, cotangent, whatever one of those 6, what's going to happen is we look at graphing unique order pairs. We're going to take order pairs from this chart, but the order pairs that we're going to graph are going to be a theta, okay, comma, one of these, either the x-coordinate or the y-coordinate. Is it okay? So I'm going to say y-coordinate, because I think we talked about this the other day. If we've got, in the unit circle, we said if I go sine of theta is equal to y over r. That's the definition of the sine function, right? For any circle, in any triangle. But if r in the unit circle is 1, sine of theta is equal to y. Does that make sense? Well, remember, this is a function, right? In a function, that's your input, that's your output, right? Does that make sense? Isn't that an ordered pair? Input of theta, output of y, correct? So what we're going to do is we're going to take a bunch of ordered pairs. Like my first order pair is going to be 0, 0. My second order pair is going to be pi over 6, 1/2. And then pi over 4, radical 2 over 2. Does that make sense, everybody? And in order to do that, what's going to happen is we're going to take our information from the unit circle, and we're going to have to take out, and I'm going to have to, okay, so right now it's in degrees, which we're not really going to deal too much with just because it's a pain in the butt. Would you want to, if I asked you to graph something on the x-axis, would you want to write out to 360? No. So usually we go, and it's more natural to go in radians. So I'm going to find my endpoint there. Should have done that before I showed you guys this. But what we're going to do then is we're going to have to take because all these points that we're going to graph here are going to be a theta or a t distance, comma, our y value. We want to make sure that we have the correct x values on here. So if I'm going to cut this in half, I'll get pi. Cut this in half, I'll get pi over 2. Cut this in half, and I'll get 3 pi over 2. Does everybody see how that is those positions off our unit circle? Okay. Now, I also want pi over 4. So there'd be pi over 4. There'd be 3 pi over 4. 5 pi over 4. 7 pi over 4, right? And I get those just by cutting essentially things in half, because pi over 4 and pi over 2, they work well together, right? They're halves. The next ones are pi over 6 and pi over 3 intervals, okay? And we're just going to use pi over 6 as our index, but pi over 6 is about right there. It's closer to pi over 4 than it is to 0, right? So I'll take that index and basically just keep repeating it and coming up with these other x values within here. Is that okay with everybody? So we need to be able to understand how these radian measurements here get converted back into the x-axis in their correct order and their correct placement, okay, to scale to one another. Because when we end up graphing the sine function as a theta, comma, the y value from the unit circle, we end up getting that curve there, okay? Have you guys started talking about sine waves, cosine waves, anything, sound waves, light waves, that kind of stuff in physics yet? You're doing what? Heat? So eventually you're going to start working with these, and they are developed through the use of the unit circle. Does that make sense? Okay. We talked the other day how electromagnetic waves from your computer talking Bluetooth to the router. Okay, AM, FM. We talked about that in this class. Or was that my geometry class? We did talk about it in here. So an AM, FM radio. Okay, AM stands for amplitude modulation, FM frequency modulation, right? It is an alteration of the sine and cosine waves, and they're encoded based on their amplitude or their frequency, basically the compression or expansion of them horizontally, and then my radio or tuner will be able to decipher that code that is written inside that message. Does that make sense? Or that wave. They're bouncing off you right now. There's all types of electromagnetic waves bouncing off you right now. Your cell phones, okay, communicate that way. Bluetooth is that way. Anybody make breakfast this morning in the microwave? You know how that works? Yeah. Okay. Why when you put foil or metal in the microwave does it blow up? Okay. You know how microwave works? I forget what the device's name that is in your microwave that creates this thing. But it creates electromagnetic waves. Okay. And the electromagnetic waves emanate in sine and cosine fashion. Does that make sense? And what they do is they start making molecules vibrate. Okay? And what molecules are in the food that you put in your microwave? Molecules of what? Water. Okay? So what it does is it forces those molecules of water to vibrate and they rub next to each other. And what happens when they rub next to each other? What's created? Yeah, friction's created, right? And heat is in a byproduct of that. So then that, I put a baked potato in the microwave, and I can cook a baked potato in 5 minutes, right? In a microwave, because it cooks from the inside out. Cook my baked potato in the oven. How long does it take? 45 minutes to an hour. Okay, because it bakes from the out. The heat is coming from the outside in. Does that make sense? Okay. So electromagnetic waves. And the science behind that is due to the mathematics that we're looking at now. Does that make sense? Okay. Can't put metal in there because how much water is in metal? None. So it creates I don't know what the issue is, but you guys talk about heat being a conductor or metal being a conductor of heat, creates a very, very hot object, right? Okay. So that just kind of giving you a foresight of where all of this stuff is going. Obviously, all that stuff is so much more technical than what we're learning in 10th grade, 11th grade, 12th grade trig, but it's the foundation of those things. Yes. Yes, because of this, we had sine. The other day we said sine theta equals y over r, right? Cosine is x over r. So when r is 1, we get sine of theta is equal to y, cosine of theta is equal to x. So let's kind of make a connection to what has happened in other courses. Right here I've got talking about college algebra, okay? This is the same, it's just a different graph I've created here. But the blue one is the cosine function. The red one is the sine function, okay? Does it look like I could take one of those and slide it left or right, do a horizontal translation, and create the other one? Yes. And the relationship between that is sine and cosine. Sine and cosine. What's the difference in those two words? Co, right? What's co refer to? Okay, so think about our right triangles. We always do sine and cosine of what angles in the right triangle? Do we ever do it with the 90-degree angle? Do I ever ask you what the sine of 90 degrees in the right triangle work is, or cosine of 90? No, we always work with the acute angles, right? The acute angles of a right triangle are always what to one another? Complementary. What does the co and cosine and sine, what do you think that refers to if we just talk about it? It refers to complementary. So what we get here is that if I move one of these 90 degrees in one direction, okay, or pi over 2 radians, I get the other one, right? Take the blue one, okay? If I take this blue one, okay, and take that point right there and move it right there, how far does it have to move? Pi over 2 radians, right? Pi over 2 radians, how many degrees? 90 degrees. Okay. So that relationship is going to be something that we realize from, obviously, the information we talk about transformations in college algebra, now coupled with this trigonometry concept. Okay. But as we go back to the unit circle and we look through this, I'm not going to fill in the rest of this with you, okay, because I think you can, because of what we've talked about. I'm just going to add this real quick. Every point, and remember, you're in the first quadrant, second quadrant, third quadrant, fourth quadrant. You're in the Cartesian plane. That's a positive, positive. No matter what point we look at there, it's positive, positive, right? Okay. Would you guys agree that 5 pi over 6 is the same thing as pi over 6? Except for every point over here is going to be negative, positive, right? Negative, negative. Positive, negative, yes? Okay. So as we talked about this yesterday and the day before, looking at reference angles, okay, and reference numbers. If I want to know 5 pi over 6, what its sine or cosine is eventually, okay, we look at this distance here instead. How big would that distance be? Pi over 6. That's my t bar value. So now I can reference this information over here, and everything that I know about pi over 6, the sine of pi over 6 and cosine of pi over 6, is identical to the sine and cosine of 5 pi over 6, or the x's and y's of 5 pi over 6, except for the signs, the SIGN signs. Okay? Does that make sense to everybody? So the unit circle is going to be a tool that I view it several different ways. I view it as something that helps us, like a, I don't know, like a, almost like a static calculator, okay? Because we're going to be using it to pull values off of it, right? To do some calculations. We talked the other day, like if I just memorize that completely and don't memorize or don't learn the relationships to help me generate it, eventually when I ask you what pi over 12 is, which is halfway between 0 and pi over 6, right? So I'm going to be asking about a 15-degree angle. There's an ordered pair that goes with it. Okay, and if I type in sine of 15 degrees or sine of pi over 12 on my calculator, cosine, it will tell me what the decimal approximation of that ordered pair is. But we'll have some sum and difference formulas, some half-angle formulas that will actually give me pi over 12, the x and y values, as exact values using radicals. I forget, off the top of my head, I forget what they are, but they're like radical 2 plus radical 6 over 4 and radical 2 minus radical 6, or radical 6 minus radical 2 over 4, something like that. But that's a hard one to remember. Does that make sense? Like these are pretty easy. These numbers aren't all that crazy. But when we do it and ask you to use double angle formulas, half angle formulas, that kind of stuff, you don't want to spend a whole lot of time trying to figure out these intermediate values to continue working those problems. Yes. Okay. Yeah. So your calculator generates that for you? What calculator is that? That is cheating. Cheater. Does this make sense? Yes. 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 And there's other relationships that we're going to find out that says, you know, if I want, let's think about this. Let's go sine. If I go sine of theta, okay, that is equal to, like, would you guys agree that sine, I might have this, no, that's bad, that's dumb. Let's write it this way. Sine of negative theta is equal to the opposite of sine of theta, okay? So sine of negative theta, so if I said negative pi over 6, that'd be that right there. Would you guys agree its y value, which would be negative 1/2, would be opposite of that y value right there? So if we ever want to deal with a negative angle, we know negative angles kind of suck, right? We can use this relationship here that says, okay, now let's just work with the positive angle and basically take that negative out front. But it's a different relationship than for cosine and a different relationship for tangent as well. I'm going to open 6-1 and WebAssign, be due like middle of next week, so it's nothing pressing right now, but you can start it.